Hi everyone, it's Sorkin. Welcome to my channel. Today we are going to solve a LeetCode 39 problem, a combination sum. So first let's read the description. So we are given an input array of integers, and we need to find the all combination that in sum give us the target. For example, in this case we have the input array 2, 3, 6, 7, and the combinations that is gives us the target is 2, 2, 3, and 7 itself. So there are two let's say important requirements. First requirement is that our combination should be unique. So if let's say that we are generated another combination 2, 3, 2 that is not qualified as a result because we already have 2, 2, 3. That would be a duplicate. Another one is that we can use the number unlimited number of times, any number. So for example 2 we can use twice, and at the same time we can use the 3 twice, the 2, 3, 4, and the unlimited number of times. Yeah, that's the requirements. So let's see how we are going to solve this problem. Okay, let's take the example that we were given, the array of 2, 3, 6, 7 as an example, and let's work on that one. So basically we have this array, and we have the target which is equals to the 7. So we need to generate all possible combinations. So we can tell that generating all possible combinations, it's a backtracking problem, so we can qualify it as a backtracking problem. And so for the backtracking, we need to, first thing that we need to do is to specify the base cases. So base case in this case would be that our sum either should be equal to 7. In that case we backtrack, or it should be more than 7. Okay, so that is our base case. So let's generate our tree. How we are gonna generate our tree? So first is let's say take 2. So we can use the any element. We will use our element until we either hit our base case or we are exceeding our base case. So for example 2 we can use once, then we can use it's not equal to 7, and it's less than 7, so we can use it one more time, 2, 2. We can use it one more time, that is 2, 2, 2. And we can use it one more time again, so that would be 2, 2, 2, and 2. Okay. So what happens in this case? In this case is that we hit our first base case, which is our sum is more than 7. So in this case we can no need to go further. We are backtracking from this solution. Okay, we exhausted all possible combinations for 2. Now let's go to what's the next element. So for 2, 2, 2, we considered also a combination with the 2, and let's consider combination with the 3. So basically 2, 2, 2, and 3. So in this case we are again backtracking from our solution. Okay, so another one would be 2, another one would be another one is 2, 2, 2, 6. Again we are backtracking from here, and we are backtracking also from here because it's more than our base case, more than 7. Okay, so the last one is that we need to for 2, 2, 2, and the 7. In this case it's also more than our base case, so we are backtracking here. Okay, so we exhausted all possible scenarios for the 2, 2, 2. So we consider 2, 2, 2, 2, 2, 2, 3, and the 6 and 7. So we can backtrack from this branch of our tree. So what we need to do, we need to consider the next one. So the next one is for 2, 2 is 2, 2, 3, right? So 2, 2, 3. So in this case, is it qualified as is it equals to our base case or more than our base case? It's actually exactly equals to our base case. So we are adding this one to our solution. So what's the next thing? Next thing is that we need to generate for 2, 2, 2, 2, 6, and which is which is more than our base case. So we are backtracking from here, and another one would be like for 2, 2, 7. We will again backtrack from that branch. I guess you get the idea. So the same way, exactly the same way, we are going to generate for the 3, we are going to generate for the 6, and we are going to generate for the 7. If you will generate, so you can actually practice yourself just to see that how exactly the tree, because the most important thing in backtracking problems is that to know how exactly you're going to generate the tree. So once you know that, once you can visualize that, rest of that is just fall in place. So you can practice how you're going to generate to 3 and 7, and you will see that there is no solutions, and we will backtrack from every branch. For the 7, we have only so for the 7, so the first combination that we take when the 7 itself, actually this is our another solution. All right, let's put the tree that we generated into the code. First thing that we are gonna do, we are gonna create a method, and we are gonna create a backtracking method for generating our tree. Let's call it just the backtracking BT, and it's gonna take as an argument our candidates first. Also, it's gonna take our target that we are receiving, and also we need to create a result to return, and it's a list of integers. So let's put here integer, and let's just call it simply result. And also we need one temporary array, also integers. So basically what we are going to use that for is, as we go over our tree, we are going to add each element to our temporary array list, and if that is the qualified at the moment, that if the combination is equals to target, then we are going to add that temporary list to the result. So let's just call it temp, and also we need to keep track the beginning of the tree that we are generating, so from which position we are generating in the next backtracking iteration. So let's call it just let's say start. Okay. All right, so first things first, let's put the first for loop here. So I in this case is going to equal to our starting position, so it's going to tell from where we should start. The next one is that so we should put the condition for that it should be equals to candidates less than candidates length, and we're just gonna increment that. So as we go over and generate our tree, we are gonna add that to our candidates. So to our temp list first, and we are adding that here. So we are gonna add candidates I. Another thing is we are going to backtrack. So basically, again, we are going to pass our candidates we are going to pass our here. What we're going to do, instead of adding the sums, combination sum, and the comparing with the target, we are going to subtract from the target and to see that if the target is equals to 0. If the target equals to 0, it means that that combination is the combination that we need. For example, in case of the 2, 2, 3, we are going to first subtract the 2. We're going to have 5, then we are going to subtract another 2, we're going to have 3, and then we subtract 3, we're going to have 0. So it qualifies, we are adding that combination to our result. But if it exceeds, so it means that if it's less than 0, so it means that we have exceeded our target and we need to backtrack. So we are going to do that in a bit reverse order. That's easier to code. So that's why we put here target minus so target minus candidates I. So the next one is we are going to put here result that we are going to pass through, and we will put the temp and the position that we are keep tracking. Also, another thing that we need to do, we need to remove from our temporary result our latest element that we have added. Let's say we are backtracking and we need to clean our temporary array. Otherwise, it will have all the elements that we have added as we go and generate our tree. So for that reason, we are removing, as we are backtracking, we are removing from our temporary array, we are moving that temp size -1, basically the latest element that we have added. Yeah, that's it for our for loop. That's how exactly we are going to generate our tree. So we are going to use, for example, let's say that the 2, we are going to use 2, 3, 6, 7, right? So we are going to use 2 here. We are going to 0 element we are going to use until we hit our base case, and the base case for that would be like a 2, 2, 2, 2. So when we are using 2 4 times, and at the time we are going to backtrack. So that's why we are passing here our starting position, I position. Okay, now let's put our base cases. The first base case that we have agreed is when the target is less than 0. If the target is less than 0, we are going to just basically return. Okay. Another thing is if the target is exactly equals to 0, so it means that this is our this is the combination that we need. In that case, we are going to add to our result temp. We are going to add temp to our result. But another thing is we cannot add the temp itself, because if we add temp itself, so basically that will be point. In this array, in the result, we have all results we will have. They will point to the same array list in the memory. To avoid that, what we need to do, we need to add the copy of the array list at the moment. So that way we can escape that problem. So that's why we are creating here new array list, and taking the copy of our temporary array list at the moment. Okay, so here we are just going to simply create array list, and so let's call it result new array list. And we are going to backtrack. Here, call our backtracking method. We are going to pass here candidates, target, result, new array list, and with 0 index, because we are going to start from the 0, At the end, we are going to just return our result. Okay, that's it. Let's see that have we missed anything or all is correct. So let me see. Temp integer. Yeah, it should be integer. Okay, yeah, it works well. So that's the solution. As I said, we are generating the tree, and we just put the tree that we generated into the code. And this is the two base cases that we have seen in our explanation part. That's it for today. I hope you liked my content. If you liked it, please hit the like button and subscribe my channel. And if you have any question, please leave it down in the comments. Thank you so much for your time. See you next time. Bye.